So thanks for introducing me. As Thomas said, I'm Katharina. I work with the Univertiy of Arts in Berlin. I also work at the Borås School of Textiles in Sweden, part of the time. And yeah, I'm interested in textile electronics mainly. I have a background as a product designer and interaction designer a little bit, so it's neither textiles nor electronics. This is something that I started with my PhD actually at the Design Research Lab that I just finished some month ago. So just a quick introduction of the two places that I work at. The one, Univertiy of Arts, it has many buildings. We live over there, not in one of the fanciest one, I'd say. So this is what it looks from the outside, very charming. And in Design Research Lab, we mostly do research on human-computer interaction and different aspects, mainly with information communication technology. So we have what is then a typical workshop for prototyping in different areas of human-computer interaction. It involves, as for my colleagues, for example, topics like embodied interaction, so how can you get the body and movement back into interaction with computers. It's about actually designing for people with certain disabilities and taking their point of view and then seeing how this could enrich your own life, because we're all disabled in some way in some points of our lives. And it's also about the social implications of information communication technology. As for my own work, it is mainly about textiles as an interactive medium to interact with computers. And this is part of our workshop. So you have the standard components that you need for that. It's like sewing machine and soldering iron for some of them. This is the other place where I work. It's actually, who of you knows Borås in Sweden? You do. So it is not, it is a very, quite small town in Sweden, but it's a very big place in textiles. So what you actually see here is an old textile mill, and the TextiSchool moved in there a while ago, together with the Textile Museum and a couple of companies. And they all deal with textiles in one way or the other. And this actually matches the school very well, because it is one of the places where you can learn to do textile design and textile technology as well on the level of industrial production, which means that you actually have industrial machines in the workshops there. You have a crazy amount of material to work with that you can just get from the shelves. So what you see here is then industrial knitting machines. You have like the flatbed ones and the round ones, as well as a large variety of looms that are both computerized and with the good old punch cards as well. The nice thing about this place is also you have quite a few researchers in electronic textiles on PhD level. So it's exactly this thing that you have a small community there who already deals with your topic, so you're not alone. If you do a PhD in etextiles and you do it in Borås, you actually have a few persons that you can talk to, so you have a community. And the beauty of this is that here you can actually work on industrial level, so you can work with conductive fibres and threads and standard threads, and then make patterns, make materials of your own. So the topic that I'm doing research on right now in these two places is then mainly to use textiles as a new technology to build electronics, which is very similar to what we just heard from Irene and Ebru, actually, who are doing the knitting parts to try to construct electronic elements in textile shape. And you can do this on different layers, and I have been working mostly in the area of reproducing input elements, senses, in textile shape. And for me, the challenge is actually to see then the textile production technique, which are very, very old, especially weaving is like so old, and then combine it with a very recent technology and then see how it can actually enrich electronics instead of thinking the other way around, then how can electronics enrich textiles? So it goes both ways for me. There are, however, a few challenges if you try that. And these are the four that I'm going to talk about. And one is the availability of the materials. It's the applicability of the material. It's the forms and context that you can actually find and develop, and it's the skill set that you need. First of all, the availability of the materials. Right now, we can see, especially if we look into research, that there are a lot of very interesting materials being developed in material research, like functional fibers. So you can find quite a few things in fiber form, including a lot of sensing structures, like piezoelectric fibers, for example. Shape memory materials that will, like shape memory alloy is a wire bimetal that will actually go back into its programmed shape if you heat it up, but if you cool it down, that you could just bend it free form. It's very, very interesting. You have fancy stuff like I just learned very recently about is like shape. No, it's phase-changing material. So this is actually a fiber that can store energy when you are when you're really hot and you have such a shirt on your body, then it will store energy, and then later on will actually emit it once again. So it's a very interesting thing that reacts to the surrounding. You find printed and woven batteries, even like solar panels, like very small. There's a few that are more common by now. It's like heating yarns. You have optical fibers that people actually weave with. EL, printing, ink, thermochromic inks that reacts to heat. You have photochromic inks. So you have a whole range of materials here. Problem is, when you ask, where can I get it from? Can I order it? And you get different answers. One answer is, well, no, because we have like 10 grams of it. That's one thing. The other thing is that you call, I don't know, a company like Scholler and you say, can I have this yarn? And they say like, yeah, we can send samples, but the minimum order quantity is like 25 kilos. And you're, what am I going to do with 25 kilos of this material? So it's not very practical. And as for the other case, when you have very little, you often have this situation as it's shown right here. So you have a researcher developing a material and then bring it to a state where you can actually demo what it does. So this is the material from my colleague, Anja Lund at Borås. This is a piezoelectric fiber that has a very precise response to pressure and stretching. And this is what you can see on the oscilloscope down here. But then you have that amount of fiber. And this is, if I start to work with an industrial knitting machine, you have like 4 meters alone if you go with the thread into the machine, and then before it gets knit, like one single loop. So difficult, yeah. Plus, there's always this issue, like you have the entire way from fiber to product. So even if you have a fiber, you need a thread. So the fiber is just a material for the thread, which is the next product, which then needs to be processed into a fabric structure, be it woven or knit or felted. And then, again, this is the raw material for some kind of product that you would like to produce out of it. And each of these steps actually add complexity to what you're doing. And even if you have a fiber or a thread that has a certain functionality, you still need to integrate it with the other steps that come later on. So there's a lot on the fiber and thread going on that hasn't yet made its way into these later stages, I would say. Lucky enough, there are a few materials that are available. And it's getting better and better. So we can now buy conductive thread and fabric on the internet, and it's not in 25 kilos, but we get like small spool. Good thing, because then we can actually play with it. We can experiment with what we can do with the material. It's less about the high professional, but you can also do it on a DIY level, and also as an interaction designer in a research environment. The other thing is then if you can get to these low-level materials, which are, for example, conductive threads. So they're just conductive, more or less. Some are less and some more. And then you can focus on what you can actually do with the next level, with the structure that you want to produce. Like if you have a conductive thread, can you design a knitting pattern or a weaving pattern that can actually then serve as a sensitive structure? If it's not the thread itself, then probably the woven structure that can provide this functionality. And this is also where much more interaction design comes in. If the fiber is not the sensor, but the textile structure is the sensor. Second thing is then actually the applicability of those materials. So this is actually a thing that even if you have a sensitive fiber or if you have a sensitive structure and you managed to build a sensor out of a knitted structure, doesn't mean that you can immediately apply it in a product, because there you need to assemble it. And even if you have very easy circuits, as those of you know who ever tried to build one, can be a giant mess. Very noisy sensors sometimes, and then shortcuts all over the place. So it can be very difficult to have like a clean electronic device out of etextiles. And this is actually a knitted structure that we developed at DL Lab. It's together with my colleague Pauline Vierne, and she went through the trouble of actually making a product out of this. So this is like a sensitive stool that was shown at Cebit Fair. And in this case, it's actually a pressure-sensitive matrix, a knitted matrix. And in this case, it's connected to a lamp. So if you sit down on the thing, the lamp will do something for you. And if we look at this example alone, because if you're in an exhibition context, you want things to work quite reliably. And there, at some point, you always have this problem that you have to have this assembly of etextile and standard electronic components at some point, which produces a gap, or let's say it's not a very smooth transition so far. We're getting better, but it's still quite wild. And the goal would really be to have the integration, to have all the components in a textile or fiber form and just be able to knit and wove and embroider and felt everything into a textile form, to get rid of the assembly component that we see in here. Next thing is then the forms and contexts that we can find with the electronic textiles. And there, wearables are a quite natural context for textiles because we know them so well, like textile, clothing. This is how we know textiles. It's very much that we wear it on our body. And it makes sense because it's very comfortable. So it has been used a lot for monitoring. So it all evolves around what kind of data you can get from the body, from movements, respiration, heart rate, things like that. This is an example from our own lab. This is a gauntlet that has been built for patients with carpal tunnel syndrome, so have actually pain in the wrist. And it has two sensors to measure strain on the wrist. It's very easy, like it's not very complicated. It has pressure sensors on the back and on the front of the hand. And if you put too much strain on your wrist, it will actually give you a signal. It will also monitor how much strain you put on the wrist and send it to your mobile phone. So this is, to me, a very typical case of how electronic textiles are used. They're used for movements and interactions that we do anyways. Like we move our hand and then we happen to have a textile around it and that measures what we're actually doing. And also, the second example, this is also something that we did, is it makes sense that it's made from textile because it makes the wearing very comfortable. So this is a glove that can measure the movement of your fingers and track them, and then also sense it to whatever device you want to use to measure that. And it can be used for gesture recognition, like very basic gesture recognition, of course. And there you can see, okay, if this wasn't textile, it would probably be less comfortable, and it tracks the finger movement, which is good. The other thing is then output. If you have wearables or textiles, it makes the output much more mobile and immediate. And this is an example. I think my slides are cut off. So poor Fabian gets cut in half here. This is a hat that you can use for pedestrian navigation. So it's a navigation system like you have in a car, just for walking in a city. You can choose a destination on your phone and then put it in your pocket, and the hat actually has 8 vibration sensors, and whenever you come to a street crossing, it will indicate the right direction to go. Like, bzzzt, and then you have to turn left. Yeah, this is what he's trying to show. It's because it's like tangible output, it's kind of hard to put on a picture. So he's just pretending here. And yeah, it has a compass as well. And here you can see a few of the components, like these are the tiny motors and then the lily pad and quite a few things hidden underneath. And that also makes sense if you walk around that you actually have a wearable of some sort. We also did another version, also to demonstrate that the same service can be attached to different wearables. So, like, what you actually do with a wearable and what kind of service you connect to it could be. It's a bit random, so you could change it finally as a user. And this is then the same navigation system put into a pullover. So you have the vibration motors on the shoulder, on the chest, and the back, and in between. And the compass is in the hoodie, actually. But the thing that you see here, this is not only about, let's say, passive monitoring of body movements or so, but you also have explicit input device. And these are the 2 pockets that you see over here. The 2 pockets actually act as switches so that you can switch on and off the navigation while you walk without doing this on your mobile phone, so that the entire pullover actually serves as an extension to your mobile phone. And this is an idea that keeps on reappearing in our projects, that you actually, mobile phones are very ubiquitous, so, and then things that you can put into a wearable make them very bulky. Like if you have a lot of functionality in your wearable, you use this advantage that is something soft and lightweight. So it makes a lot of sense to combine both in a way that you distribute the functions that are better put to the phone, which is then a mini computer, and it's more powerful than probably the Arduino that you have in the wearable, and the wearable which is more accessible than your phone most of the time. And another example that goes more into this direction: how can we actually use the specific properties of the textile as a medium for interaction. So this is a jacket for, yeah, for people with some kind of condition where they might need help, like heart disease or so. And this jacket can be used to call for an emergency. So you also have a mobile phone here, and you have very simple triggers. If you have a problem, if you don't feel really well, that you actually lift your cuff to the chest. And then this is just a simple contact that is being closed. But the idea is that this is something that is specific to the shape of the jacket itself. So this is a textile switch of some sort, and it's something that would look very different if it wasn't textile. And then user gets a little bit of feedback, but the main thing is actually that you have the mobile phone does the phone call to a person of your choice. And still some more. So this is called the, yeah, this is a radio hoodie. So it has a FM receiver in the middle. And the idea here was not so much to make a super convenient object. This is part of my PhD project. And the idea was rather to have a very experimental form of interface that is very much deducted from the way that you construct knit fabric. So it has 2 potentiometers, like the one that you see on top here. This is a little bell. And you see, or maybe you don't. Do you see anything? If not, there's like a little bit of conductive thread in there. And wherever you touch the bell around your hat, you will find a different radio station. And then you get these strings with a pom-pom. And this can be pulled, and there's also a potentiometer inside, like knitted contacts, and you can change the volume by doing that. And you see the knot down here with these shawl thingies, and if you close and open them, this is actually the volume. It's not the volume control, sorry. It's the on and off switch for the radio. And these sensors are built in a way that complies with the construction of elements with the hand knitting machines. So this is like something that you normally do if you have like the bottom of the fabric. This is a technique that you use for that. And then something that is, in German it's called plating. So you just knit on one side of the fabric and not the other. And the entire shape is somehow deducted from use of the knitting machine. So that was the idea. It all means that actually we have this idea of wearability as a starting point to work with textiles, but then we have the textile itself as an interactive medium that allows and affords us to do more and different things with the textile itself as an interactive medium. Yeah, and this is something that leads then finally away from garments and clothes as textile objects towards other textile objects that are more specific to enable and display the textile interactions that you can have. And this is also one of my PhD prototypes. This is a quilt blanket. And here the idea was actually that you can use folding as a textile interaction, and the blanket is made up to work just with folding. And you can somehow try to find out what the folding patterns are if you look at the pattern, like the visual pattern on like a patchwork on the blanket. But it's sort of a little bit hidden. So once the folding is unfolded, then you really need to know how to fold it back. That was the idea. That's something that is very much a process. It's not so much visible in the structure. So once you fold it, and again with the help of a mobile phone, you can record and play back audio messages. So the idea is you have like 8 different foldings, so you can record 8 different messages, and you have to remember the folding where actually the message is. So it's a little bit like this quilt blanket can keep a secret, and by mere accident, this is somehow related to the way that quilt blankets were supposed to be used in Northern America, that they can like display secret messages to people who know how to read them. And to go even further away from well-known objects towards like more strange shapes, this is the third of the 3 prototypes that I built. This is called the shuffle sleeve. So this is like a knit tube, a closed knit tube, and inside you have coins. So you can shuffle the coins around in this knit tube. The idea is that the tube is also via Bluetooth. It's connected to a mobile phone, which has a music program. So when you move the sleeve, like when you revolve it around your body, the coins will always fall down to the bottom. This is something that you probably know. You put stuff in your pocket and then it always falls down to the bottom, and it's hard to get out again. And we used this interaction of textile and little metallic objects to create a switch of some sort. So you can actually switch back and forth through your music playlist. You can also change the volume and turn the music on and off if you enclose the coins with these little knots. So the knotting strings, they're also serve as switches, and then they can feel the presence of the coins here. This is what it looks like. Here you can see the knitted contacts and controller, Bluetooth module here. So it's like, in terms of how it works, it's actually very basic. But the interesting thing is then how do people interact with it? And this is really a line of research that I find very interesting myself, then just to see what would the world look like if we had electronic devices made out of textiles in the first place. And this is another thing that this is really, yeah, we call it the donut interface. So it looks like a donut. It's a knit donut. It has 3 sensors around its length, and you can like roll it, or let's say, yeah, it's called krempeln in German. So it's like this movement of turning inside out constantly, and it can like evolve around itself. And this is like a scrolling motion of some sort. So we just created this as an example of what a textile interaction could actually look like, because this is also very unique to textiles, that you can do that. And to take this even further and relate it back to textile production techniques, this is actually an interactive knit ball. And here it has 6 senses, knit senses with like stretchable, sensitive yarn. But it's also shaped in the knit. So you see this ball structure around here. This is like one piece. So you start at the bottom and you can actually shape the knit while you knit it on the machine to in the end, form this ball shape then. And this is also very interesting then to see like what do the machines that you work with afford in terms of shapes, interactive shapes, but also then more, less familiar shapes for textiles. Like the ball is still very familiar, but this is just the beginning. We hope to go further with that. And that brings me to the topic of skills. If you build textile senses or actuators or other components, you need to have a basic understanding of the electronics, obviously. You need to have a basic understanding of the textile production techniques, and you need also to understand interaction design, which is an awful lot for a single person to do, at least in a short time. If you have like 10 years or so, it's manageable. But if you really want to understand all those things, it's actually good to have some aids on the way. It's something that you can just refer to that will serve as a little shortcut. And this is an example. And those of you who have been to the show yesterday have seen that too, that it's just a switch, like a knitted switch. So it's also sort of a pattern that you can just give to somebody who knows how to knit, and then they can reproduce it. And in this case, because if you knit this kind of pattern, you somehow need to be able to show what it can do. So here it is embedded in this swatch book, and you can activate it and then see the effect. And a similar one, this is like, this is a self-folding structure. You can do this with knitting. It's also a very fancy pattern. So now it's like pulled out, and if you let it go, then it pulls back in, and then you have like a curtain of some sort. And you can set this up to be a sensor too. So you just pull it out like that. Similar effect. And these patterns are actually helpful. So once you come up with that, or somebody else did, then you should probably stick to it, because it's so tedious to create all the different interaction elements and electronic elements in textiles. So whoever came up with a good idea, please share it, because otherwise people start from scratch. It's just nonsense. Because it's like pretty much everything that you have to recreate in a textile shape. So these patterns are one thing that we were developing. The other thing is then, of course, if you have hardware that helps you, and Arduino has been great. Where would we be without it? And then we ended up making our own version, which is again too big for the screen, I see. Because we always used the same components over and over, which was then the Arduino controller, it was a wireless module, and it was a power supply. So this is then all put together, and it uses a BLE module. And this is also because we wanted to be able to communicate with mobile phones, and not only Android, but also iOS. And there you need the BLE, otherwise it won't work. This we made ourselves, so we call it the Lily BLE. It's open source, so you cannot yet purchase it. I mean, you can purchase it for me. We have like a batch of them, but it's not on the market. Yeah, so just talk to me, and then we can talk about how to get it to you. But of course, we would like to have this somewhere sold and distributed, because we're a university and not a hardware store. So feel free if you want to do this. I don't mind. And of course, this is the controller part. There's other issues with other materials that we would like to have some engineer just being keen on producing the components. Like when you use thermochromics, for example, you need to control a heating wire or heating elements in general. If you don't control them very well, your textile might catch fire, which is not a good thing. So you would like to have the electronic setup for the kind of heating element that you have, and this is already a bit of a challenge for somebody who doesn't know electronics very well. Or electroluminescent panels, electroluminescent wire. You have some stuff already on Sparkrun that helps you, but most of it is not already set up for wearables. Some are, and some are not. But we can use more, like more of these tiny little bits that help us control the stuff. Of course, it's also nice if you have other partners, institutes that know how to do things. Like this is an embroidered version of the lily pad. You cannot see anything. What you could see here is actually, this is the atmel, and then there's a lot of embroidered lines around here that look really nice. That's what you're missing right now. And then the usual 6-pin header for programming. So this is a lily pad. It's embroidered. It's great. It's actually, the nice thing is that this is from TETW Greiz, which is a research institute in Thüringen, doing a lot of etextile stuff. And this can be done with a commercial embroidery machine. So once we know how to do it, others might be just able to reproduce it in this way and then embroider their own controllers. And it would be a step to making then also this gap less big between what we saw in the assembly part, that we have then the hard to soft transition that is always hard to deal with. Yeah. We collected the hardware and the patterns on a website, and also the software that you will see in a minute. This is a database. So this is meant for everybody who is working in etextiles. You can use the patterns that you see on there. A pattern in this case is really that if you have a component that you would like to reproduce in a textile form, probably you can find some hints in here. So we have a few ways, mostly for knitting, because we worked a lot with knitting, to produce traces with knitting, not only horizontal, but also vertical. The knitted speakers, actually, we didn't come up with that. I think this was V2. But we have a pattern here, how you can make your own knitted speaker, actually, or different interaction elements, also the pressure sensor matrix and stuff like that. And you can submit your own. So if you have a good solution for something, if you have a great sensor, great actuator, in, I don't know, woven, knitted, felted shape, you can submit it here. It would be great if you do that. We value your contributions. It's called interactex, like interactive textiles. .de. And another helpful thing here is that we have two iOS apps that should help people to assemble and program and test their wearables or other etextiles. And the idea is here that you have a workspace of some sort, and then you can just pick the elements that you want to use and connect them to a microcontroller and then assign some functions. So it had like a hardware, a software, and a testing mode. And in the hardware mode, you can actually, you choose a LED, you connect it to your microcontroller, and here you could then connect it to any pin that you actually need. And in the end, you have a bit of an overview of what your circuit looks like, if you want to sew it later on. Or you can reproduce a variable that already exists, and then assign some other function to it, as long as it's Arduino-based. And this is then how you assign the function, so you have like different elements with different events. In this case, here we have an I button, and it can be switched on, switched off, and changed. And this is what the LED offers, so you can turn on, turn off, and vary and set the intensity of the light. And you can connect the two also with like drag and drop. So it's a very easy process, so you don't need to be a programmer yourself to do that, and then you have a quick result. Actually, I have an iPad, an iPhone, and a demo with me, and I can show it to you. Like, this is a little demo test bed, and you see the leg controller in the middle, and then a sensor and few like a LED and switches here. And that's good enough to show what it does. So just come approach me if you want to see that. Like right now, yeah. Yeah, I don't, I actually, the thing is that it's still not on the App Store. We're working on it, like impatiently. And it's open source, so you can already get it on GitHub. And if you know how, then you can actually upload it to your own device. That already works. It's not yet through the debugging phase, so it crashes a lot and has some nasty bugs. But we're working on it, and it should be okay and in the App Store very soon. And then it's free and for everybody to use. So, and we appreciate comment and feedback and also contributions if you happen to be an iOS programmer with a lot of spare time and some interest in it.
There is one here.
Really? Yeah. Talk to me. Yeah. Once you set up your project is weird. There's really nothing to see. But once you set up your project, you can actually just transfer it to your phone. Then you connect your phone to your wearable, and that's it. And the nice thing is that this is also set up for end-user development, so to say. So if you have a wearable and you are not satisfied with what it can do, you can actually reprogram it for yourself. Yeah, and that's about it, actually. So conclusion is that etextiles, it is like turning electronics textile, is a very tedious thing. It's yeah, it doesn't make sense to electronic engineers who think you can just pick the components from the shelf. Why would you bother to make them textile? But it's so very exciting and interesting. And I think we're just at the very beginning when it comes to application context and shape and interactions. And I'm actually curious to see what more people come up with in the community. Thanks.
So, Andy, are there any questions? But you were first. Wait.
It's also called Interactex, and it's actually, you have the information on the website as well. And you can, I forgot to say that, yeah, we have a newsletter, and you can just subscribe to the newsletter to learn, because the contribution form is also not quite ready. This is like, but sometimes it's like that. So you can subscribe to the newsletter, and we will let you know when you can contribute on the website, which should be in a few weeks, when the app is online, and you can use it for yourself on whatever news we get out otherwise. So we won't spam you, we just put out the important information. It's Interactex, and actually Pauline has some cards with the web address on it that I can, yeah, it's just right behind you. So please get some of the cards, but I can also go back. The thing is that you cannot see a thing. So this is like Interactex. It's like interaction, no, text. Very clever name. Yeah.
Wait.
Thanks. I just wanted to ask you if you did conduct any research on the health implication of plugging a compass on your brain.
No, I don't, actually. I know that this is an issue every now and then, and again, I'm not an electrical engineer, so I know very little about the implications of what's it like, the electrosmog, so to say. And people keep on asking, and they are concerned actually. Also, just when it comes to wear electronics on your body, this is something that I hear a lot. And do I get shocked? And I say, probably not. It's not a lot of voltage here. You should get out the battery when it rains. But of course, it's an issue, you're right. And I don't know. And I also, yeah, it would be interesting if it has implications. Once I talked to my brother, and he's a mathematician, and he said, like, you know, there's more radiation coming from space than from your mobile phone. But I don't know if he's right on that. So I just don't know.
How reliable is the textile sensor?
Wait a minute. Say it again, please.
So in the hardware world, the reliability is very important. So I'm just wondering, how reliable is the textile sensors can be?
That depends on the sensor. So the sensor that you have seen right here, this is really just a contact that is made. So it is very reliable because it's just two open ends, two contacts that meet, and they have a large surface. For this specific prototype, the reliability issues lie more in the Bluetooth connection, I guess. So of course you don't want data to be lost, and then you make an alarm and nothing happens. And there we have feedback system. Like you should be able to tell if your alarm was actually successful or not. But reliability is an issue for all textile sensors, that they can be very noisy indeed. And this is one of the challenges, is actually to get a reliable response out of an textile sensor most of the time.
Thanks.
Yeah. Do you by any chance also work with solar fibers?
With solar fibers?
As in fibers who can transform sunlight into electricity?
Do you have some? Where can I buy it? This is exactly...
No, I was at this TEDx event a couple of years ago, and
yeah.
I met this team, and they were working on a solar fiber.
Yeah, this is exactly what I mean when I talked about the availability.
Yeah.
I'd love to. Give me the contact. Because this is very interesting. It's just then once you try even to find out who does that, and if you get any of the materials, it can be very hard. So, yeah.
Hi. Could you comment on the challenges of washability and sort of where that is now and how you might see that being an issue moving forward with these devices?
Yeah, washability is awful because obviously it destroys the electronics most of the time. So if you wash things, it's very hostile to the electronics. And most of the time it means to take away some of the charm that you have with these handmade etextiles, is that you can coat it, and you can of course use coated materials in the first place. You can make things detachable so that they're not affected by washing detergent. But it is a challenge. I always put it like that. I mean, you have a few things in your wardrobe that you wouldn't wash. Like if you have a tuxedo, you wouldn't wash it. So you have to think about wearable etextiles in a way that they need special treatment because they are special devices. And for me, it's also one more reason not to think about etextiles exclusively in the sense of wearables, but also other things, because you don't wash your sofa very often. That is an advantage when it comes to etextiles.
So you talked about the variable
Wait a minute. Take the mic, please.
You talked about the variable input. That was an interesting concept. Can you explain further what you have studied?
What do you mean exactly?
So the variable input, like when you touch, is only one input. But when you talk about variable input,
wearable or variable?
Variable. Variable.
Okay.
So, like when you do programming, you have variables. The variable is what interaction can be more complex. So, are you? I remember you talked about concept in etextile. You can also do the variable input. I was wondering if you could expand on that idea a little bit more.
Okay, I don't know if I understood you right, but I will try. Okay. The idea is that the connection between input and effect is a bit random when you have any sort of interface. Which means that, let's say you have a jacket and it has a trigger, and you are, I don't know, heart disease patient, and then you would like this trigger to call the emergency service. But then you're another person and you don't have any heart condition, so you would like this switch to trigger the music player on your phone so that it will start and stop playing music. The idea is that we don't know yet what context etextiles are most useful in. We can sort of guess, like health is one thing, and then sports maybe. But there might be other uses, and most of the time uses are most creative when it comes to finding specific problems that they want a solution for. And this is why this idea of variable input-output couplings came up.
Thank you. Yeah.
Yeah, I was wondering in which field you think is the biggest potential for these wearables. Is it more like medical technology or consumer products? Yeah.
I like the idea of having interfaces for animals, because I mean we barely do research in that area, but it's somehow a nice idea to have wearables for animals like dogs and cats and horses. I know this is already being done, and I just like the idea somehow. It's more an interest of mine. And as for the other application scenarios, yeah, like smart home environments is another context that is under investigation. And other than that, I honestly don't know, because we don't know. We have to find out.
Questions?
You had mentioned, I heard you mention that past sensors, you're really interested in working with what actuators could be done with the etextiles. I was wondering if you were looking into like what actuators in particular were holding your interest, or if you've done any research into things yet.
Yeah, currently, I mean, what already works is this auditive output, which is great. So this is like a knitted speaker coil, and then you still have to add a magnet to make it work. But then it makes sound. It's great. It's exciting. So auditive input, check. You have that. Heat is great, as I say. That is quite well investigated. Nitinol has also been done, and right now I'm working with nitinol, and I think it's nice because it's so much related to like the textile that can shape change, and this is just very interesting because textiles are so fluid and flexible, and then if we have this shape changing aspect to it, to me it somehow feels like it's very natural when you work with textiles that you could somehow affect the shape as well. Plus it's something that is not related to, if you talk about heating up textiles, and you usually think about like jackets that can heat you up, or like the heating blanket that you have at home. But the shape change is just like, whoa, what's happening? And I mean, there's a couple of researchers and artists in etextiles who have done that before, and it's still a bit difficult, but I'd like to see more of that as well. And I don't know, what else? We can just go through all the outputs that we can think of and then think what they might look like. And for quite a few, there exists something, but it's not at a stage of maturity that you can readily use it again.
Are there any questions? So, if not, thanks a lot for the great talk.
Thank you.